Okay. So last time we did, like, it was introduction to matter in solid liquid gases, and we did properties of solid liquid gases. So we did a little bit about interconversion of matter also. Okay. So yeah, we just saw the definitions of what all interconversions happen here. The first one, when a solid is turning into a liquid. What is this called?
Melting.
Melting. There's an alternate name to it. Do you remember what it is?
Fusion. Is it fusion?
Fusion. Yes, fusion is correct. Okay. So Hani, so
Yeah.
tell me this one. Liquid turning into a gas.
Evaporation.
Which one? Evaporation is a specific, like, it's like a special case of this conversion. Like, this conversion is happening, but that's not what we use for like any liquid turning into gas. और क्या बोलते हैं इसको? Vaporization is correct. Yes. Vaporization or also boiling. Okay. So again, make it a habit that whenever you come across liquid turning into gas, go for vaporization or boiling. Like, your first instinct should not be evaporation, because that's like the most common that you see in everyday life. But that's a special case of this process. It's not when we talk about energy changes and all that, like, evaporation is not something we consider normally. Default nahi hai wo. It's a special case. Okay. Solid turning into gas.
Sublimation.
Sublimation, yes. And uska reverse, gas turning into solid.
I can't do it.
Think of a gas like vapors hai. So that is turning into solid. तो क्या हो रहा है? So
That was from D, I think.
yes, starts with D. Suhani, do you remember? Okay, check your notes and tell me.
Deposition.
Yes. Deposit हो रहा है solid. So this is deposit. ठीक है. Then, okay, gas turning into liquid.
Condensation.
Yes, gas to liquid is condensation. And liquid turning into solid.
Freezing.
Freezing, yes. Okay, so all these processes, you can like write it side by side. Like these two, you can write it side by side, taki you have that connect. Liquid gas, one way is vaporization, the reverse is condensation. Solid liquid, it's melting fusion, or the other way is freezing. Okay. All right, Ashmi is connected. Hi, good afternoon, Ashmi.
Hi, good afternoon.
What happened?
No, I was trying to join,
Mm-hmm.
but I couldn't sit. took me some time. I'm sorry.
So this happened last time also, no? So that's the reason we send the link earlier. Why don't you try and connect at like 4:25 itself? So that
No, actually, I reach home by 3:30. So then after that, I have my lunch and then it takes time. So that's why. But I'll make sure it does not happen again.
Yeah, yeah. ठीक है. So अगर ऐसा कुछ हो रहा है तो just put it on the group कि at least I'll know whether you're coming, if you're trying. अगर कुछ solution है तो we can figure it out. Okay. So try to connect earlier so that अगर कोई technical issue है तो you have time to sort it out. Otherwise put it on the group कि you're trying to connect but it's taking time. At least we'll know कि okay, you're going to join.
Yeah.
Okay. All right. Where's your video?
Yeah, 1 minute.
Yeah, we're just like recapping what we did last class. What about Meg? Where is he? Any of you guys like friends with Meg? He's not seen the message also. What happened? He'd come to school, right?
Yes.
Okay. Okay. Just pause. Yeah. So when we talk about heat energy or temperature, number of molecules matters, yes, but it's also the motion of those particles. So if we have equal number of particles and एक में ज़्यादा motion है, एक में कम motion है, then whichever has more motion will have higher temperature, because more motion, like it could be faster vibration, it could be vibration along with like moving here and there. So अगर ज़्यादा motion है मतलब ज़्यादा kinetic energy है, ज़्यादा kinetic energy है मतलब ज़्यादा heat energy, and heat energy is what you measure, what temperature measures. So ज़्यादा heat energy मतलब higher temperature.
Must kinetic energy leads to heat energy.
हाँ, like when we talk about heat energy of an object, it is kinetic energy of all the particles. So body ka kinetic energy is completely different. That's not what you're considering. Like body is at rest, uska velocity nahi hai, uska kinetic energy nahi hai. But this body is made up of individual atoms, right? And last class we said agar solid hai, even though it's a solid and all of them are rigid, tightly packed, they still move in their place. Tiny motion will be there. So that motion is what we are considering. So particles ke sare kinetic energy, like kinetic energy of the particles that make up the matter, that physically, like obviously hum atoms or molecules ko nahi dekh sakte na. So physically what we feel, like this particular energy, what we feel is the heat energy. Okay, so once you got the topic, I'll show a simulation. अगर एक visual है तो it will be more intuitive, like you guys can see what it means. Okay, are you guys able to see the screen?
Yes.
Huh.
Yeah.
So let's take water only. Okay, so abhi the temperature is 146 Kelvin. Do you guys know the scales of temperature, units of temperature? पढ़ा है पहले. What are the different units of temperature?
Yes.
Degree Celsius,
Degree Fahrenheit and degree Kelvin.
Kelvin. Okay, so you guys are aware of Kelvin, right? And do you know what 146 Kelvin means? मतलब if you convert Kelvin to Celsius, कितना होगा ये? Like, do you know the relation between Celsius and Kelvin?
Because we had learned about it.
You learned about it, लेकिन याद नहीं है? नहीं? Okay, if you don't, we'll will show that. Then it'll like make slightly more sense. Where is temperature? Conversion temperature. Yeah. Table is here. If you want, you can note it down. From 2. So if you want to convert Fahrenheit to Fahrenheit, like equally yoga, like 3 degrees F matlab 3 degrees F ही होगा. If you want to convert Fahrenheit to Celsius, then this is how you read this table. Okay. So Fahrenheit to Celsius. So degrees Celsius will be equal to, this is the formula. So Fahrenheit में जो भी temperature है -32, this whole thing is multiplied by 5/9. And if you want to convert Fahrenheit to Kelvin, so basically Celsius में convert करके add 273. नहीं, add नहीं, subtract होना चाहिए. Kelvin is smaller than Celsius.
And which one?
So if you want to convert, like focus on this one. If you want to convert Celsius to Kelvin, so Kelvin is whatever temperature you have in Celsius. नहीं, I'm sorry. Plus 273. This is correct. Yeah. Celsius to Kelvin matlab whatever temperature you have in Celsius, you add 273.15 to it. Kelvin को convert करने के लिए you have to subtract it. Okay, so note down this table, then I'll explain each one. Fahrenheit से, Celsius से, and Kelvin से क्या क्या कैसे convert करना है. So इसमें remember only two things, that it'll be easier because the others are anyway derivations of that only. Remember Fahrenheit Celsius के बीच वाला conversion, and remember Celsius Kelvin के बीच में जो conversion है. So remember one of these two, like both of these are reverse of each other. Fahrenheit Celsius का कोई एक formula याद रखो, and remember Celsius और Kelvin के बीच में this conversion. Then it'll be simpler. You'll be able to handle any conversion that's there.
Miss, we need to write this down.
Yeah, note down the conversions. Because now we're getting into effect of temperature. No, you need to be comfortable with how to read temperature and कौन से scale में कैसे होगा, all of that. Yeah, it'll be helpful. Like if you know what is like a really high temperature, what is a really low temperature, it will help you figure out कि okay, अगर temperature इतना है तो solid होगा या liquid होगा या gas होगा. Just make it a little easier. See, again, you don't have to copy it exactly as it is. tabular अगर आसान लगता है तो you can copy it, but if you think it's easy to write it as bullet points, then you can do that also. You can be like 2 Celsius, so degrees Celsius equal to formula, then degrees Fahrenheit equal to formula, then Kelvin equal to formula. Like SAB, you can just write it down. Whichever is easier for you to revise it future में. Revise. पढ़ने में आसानी होना चाहिए. That's the main intention.
This is Fahrenheit, you put a degree sign, right? It's
Yes.
a degree Celsius, degree Fahrenheit, and it's only K.
Correct. Fahrenheit में degrees.
That's a mistake.
Yeah. Everywhere you see degree, like when you're expressing units, no, final answer or whatever it may be, whenever you're writing Fahrenheit and Celsius, degree absolutely needs to be there. यहाँ पे हो सकता है because it's a number variable है तो it's not given. So this minus again because it's in a box थोड़ा formatting ऐसे हो गया, but this is K minus 273.15. इसका बिल्कुल रिवर्स है.
Done.
Huh? Cool. Okay. So Hani, Ashmi, just let me know when you guys are also done.
Yeah.
Okay. All right. So, okay. So now that you have the formula, let's get back to this. Okay. यहाँ पे temperature दिखा रहा है 146 Kelvin. तो ये vessel में we have some water. These are water molecules. So 146 Kelvin पे है मतलब what would be the state of water? Like Celsius में convert करके check what is the temperature यहाँ पे. So 146 Kelvin will be how much Celsius?
So my 146 Kelvin minus 27 3.15, right?
Yes.
Is 146 minus 273.15, how come?
This would be minus 127.15.
Minus 127.15.
15.
Okay. Okay. So it is at this much degrees Celsius. So water का state क्या होगा at this temperature?
Solid. Frozen.
Frozen solid, yes. So this is what ice looks like. So even in the solid state, you can see that structure is rigid, but can you see these molecules like continuously moving? Like focus on one molecule. It is not moving from its place. Look at my cursor. यहाँ पे ये जो molecule है, इधर ही है, but within its place, it's like continuously moving इधर उधर, right? So this is the kinetic energy that we are talking about. Particles are always moving. Universe में ऐसा नहीं है कि any particle is like, any atom or molecule is like just there. It is never stationary, always in motion. Okay. So theoretically, so Kelvin exists purely because of that. So 0 Kelvin pe there is like no motion at all, which is practically not possible. So this does not exist in the universe. Scientists have tried liquid nitrogen, liquid helium use करके. They have tried to bring it down to 0 Kelvin, but practically nobody has been able to achieve that. Universe में ऐसा कभी हुआ ही नहीं. The lowest temperature that was possible that they brought it down to was 0.15 or 0.015 Kelvin. So something like that. I need to check it again. But this was the lowest they could get it to. 0 Kelvin kabhi possible ही नहीं हुआ. But at this
And this is the temperature.
yeah, that will
So
be
why is the temperature not possible? 0 Kelvin.
0 Kelvin temperature is not possible, because at that point it would mean that all the particles would stop moving. And also there's like relation with temperature and volume के साथ relation है. At this temperature, volume should technically become 0, but obviously it won't be 0 because atoms, molecules are still existing. They won't just disappear off. So baki sara, like there are things practically that make this not possible. But yeah, the deal is that this is the lowest possible temperature. In reality, this does not exist. People have gotten it down to like 0 point something Kelvin, but never 0 Kelvin. Theoretically, टेम्परेचर पूरा जीरो है, मतलब देर इज नो मोशन ऑफ पार्टिकल्स, ये पूरा स्टेशनरी बन जाएगा. बट या इट्स एट दिस टेम्परेचर. So even ice, even at like 127, 128 degrees Celsius, you can see that the particles are still moving slightly. थोड़ा सा vibration है, मतलब उनमें अभी भी थोड़ा सा heat energy है, this kinetic energy with them. Now let's see what happens when you increase the temperature. When I increase the temperature, it's come to 294 Kelvin. 294 Kelvin मतलब Celsius में कितना है? Like, what has this become now?
Yes, 21.15.
20 कितना?
1.15.
21.15 degrees Celsius. So अभी क्या हुआ पानी को at this temperature?
But how much did you get?
294 Kelvin, 21.15 Celsius.
Miss, I got 20.85.
So subtract, 20.85 hoga. Yeah. Just take care of calculation, huh? So essentially 21 degrees. So it would be 294 minus 273.15. हाँ तो यहाँ पे 0 हो गया ना, कैरी ओवर पे you should get 20.85. Yeah. Okay. So what would be the, like, what happened to this same water H2O at this temperature? So at 146 Kelvin, it was frozen solid ice. Ice का structure भी देखा हमने. Heat करने के बाद क्या हुआ when we increase the temperature?
Sorry, the movement within the molecules increased.
Yes, you can see that movement increased. Also,
Yeah.
water is liquid room temperature पे 0 के above तो liquid है that water. So focus on any one molecule. Let's pick this. So movement vibration से थोड़ा ज़्यादा increase हुआ. Molecules have started rotating, and also this molecule has been moving away from its place. Like all of them are moving against each other, which is the speciality of liquids. So you can see even the arrangement of particles. जब ice था तो it was quite rigid in structure. When it became liquid, they're still close to each other, but now free flow is possible. They're able
Miss,
to.
do we have to note this down कि when it's heated, so what is the movement?
No, I'll tell you when to note it down. Okay, so chapter is proper points. I'll tell you. Like now, focus on like understanding what is happening here. Do that.
Okay. So in heat, the kinetic energy is higher, right?
Yes, more
And
movement. Yeah. So more.
and while it's cool, it's not higher.
Yeah. And then when we heat it further, let's bring it to above. अभी 401 Kelvin है. So 401 Kelvin मतलब what is the temperature?
Miss, in any molecule, if you heat it, the kinetic energy increases. So like there would be more motion in the molecules.
Yes.
In any substance.
Yes.
It would be 127.85.
Yes, miss.
27.85 degrees Celsius.
85.
So at this temperature, what does water become?
Vapor.
Vapor, steam, gaseous state बन गया ना? Which you can see कि like when it was ice, it was in one formation only. Liquid में भी नीचे ही था. Abhi once we converted into steam, they started flying around everywhere. So motion of the particles increased, kinetic energy of the particles increased. So you can see there's a direct correlation. अगर temperature increase कर रहे, change कर रहे, तो particles में भी ज़्यादा energy आ रहा है, and like you can like base the characteristics of solid, liquid, gas is that only. Like kinetic energy of solids is lowest, फिर liquids, and gas में it's the highest. So change in temperature में you're essentially increasing the kinetic energy in the particles. इसलिए the phase is also being transformed. That is why you have the conversion from solid to liquid to gas when you increase the temperature of the particles. Okay, so that's how those two things are related to each other.
Miss, what is the coldest temperature
Coldest, let's
for
check it out.
Kelvin?
Coldest possible temperature. 0 Kelvin, absolute 0 is this thing. Coldest. Let's see. Absolute zero marks a spot where lowest possible energy hai, but achieved in, yeah. Let's look at the Wikipedia. So outer space has a temperature of 2.7 Kelvin. It's not quite zero. It is a little more than zero, 2.7 Kelvin, but this is what we're talking about in outer space. Laboratory mein, let's see. See, nothing in the universe or a laboratory has reached absolute zero. Space has background temperature of 2.7 Kelvin. और इधर है, let's see. Laboratory में क्या आया? The question whether there's a limit was posed in 1702. Then they started recording it. Theoretically, they knew that they could get to minus 273.15, which is 0 Kelvin. And as technology increased, people tried to achieve that. But let's see which is the lowest they have achieved. There you go. Absolute zero cannot be achieved. It is possible to reach close to it, temperatures close to it through all of this technology. Oh, the use of laser cooling has produced temperatures of less than a billionth to Kelvin. Okay. Oh, this record even I didn't. It was set in 2021. Last year ही हुआ. That's why I did not know this. So this was the lowest ever temperature that was possible, that was recorded. 38 picokelvin. So pico matlab 10 raised to the power. So they have done it at 3.8 into 10 raised to the power. Kitne zeros hai? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Minus 11 Kelvin. So this is the smallest temperature people were able to get to. Close
So
to
this would be something minus in Celsius, right?
yes. So this would be almost equal to minus 273.0000 something degrees Celsius. Okay. So 0 Kelvin is minus 273.15. तो इससे थोड़ा सा ज्यादा. So 273.10 or 100000 and so on. 11 zeros के बाद.
The lowest temperature could be zero, but it is not possible, right?
Yeah, theoretical is zero, but in reality, universe में या laboratory में it is not possible. You can get as close to zero as possible, but you'll never get like proper zero at all. Never. Okay. Yeah. So that's all about temperature. And we also saw how it is possible for interconversion to take place by changing the temperature. So let's see what this has to say.
Excuse me, miss. Miss, if anything possible, anything near zero is possible by all of the technology. Then why not zero if there is proper?
So there is a
So
reason.
miss, is it like
So that relates to gas loss and all. So the like when it comes to gases, like temperature is also related to the pressure and it's also related to the volume of the particles. Now, how it is related to pressure, that also we'll see. Like once we talk about temperature, we can also change, convert matter from one form to the other by changing the pressure also. Once you have like understanding of both of those, then we'll see how it relates to volume I'll try and explain it the best I can, but we'll go deeper into this exact thing. Why can't we get to 0 in grade 11? So it has to do with the volume. तो टेम्परेचर और वॉल्यूम का भी एक रिलेशन है, एंड बाय दैट रिलेशन अगर टेम्परेचर 0 होता है तो वॉल्यूम भी 0 होना चाहिए, बट रियलिटी में वॉल्यूम कभी 0 हो सकता है क्या? लाइक इफ यू हैव मैटर, उसका वॉल्यूम 0 बना सकते हैं क्या? नहीं ना.
Basically, it's scientific reason, not the lack of technology or something.
Yeah, it's a scientific reason. Technology. Okay, so that's how you convert matter. Like that is the reason why if you change the temperature, solid, liquid, gases also change from one form to another. So when you're increasing the temperature, you're giving that matter more energy. इसलिए it goes in the direction of solid से liquid, liquid to gas. When you're cooling it, you're taking energy away from the matter. एनर्जी डिक्रीज हो रहा है, इसलिए अगर गैस है तो वो लिक्विड बन जाएगा, लिक्विड है तो वो सॉलिड बन जाएगा. ओके, there are some terms related to it, so this also you guys are very familiar with. The first is fusion point or melting point, or fusion or melting point. Fusion पता है, it is the process of conversion from solid to liquid. This part is important, this would be new to you. So any random conversion, you can't define it as fusion. It is at specific conditions of temperature and pressure. Yeah. Fusion is specific conditions of temperature and pressure. So even when you wrote the definition, you must have mentioned, you know, at atmospheric pressure or at its melting point. ऐसे करके phrases रहेंगे ना definition में. So that is important to specify that it is at specific conditions of temperature and pressure. That is fusion or melting. So this particular temperature, जब melting होता है, this definite temperature at which a solid starts melting is called melting point of that solid. तो हमेशा any matter you take, whether it's wax, whether it's oil, whether it's water, whatever you take, melting doesn't happen at range of temperature. It will always happen at one specific temperature only. Melting हमेशा once that solid hits the melting point, तभी melting will take place.
Do we need to write this down?
Yeah, write it down as two separate things. Like fusion, already you've written it down, right? So just write the definition for melting point. Just a moment, guys. Write down definition of melting point from here. Freezing point, melting point. There you go. So melting point of a solid may be defined as the temperature at which solid melts to become liquid at atmospheric pressure. So that specific conditions of temperature and pressure, temperature is supposed to be melting point and the pressure is supposed to be atmospheric pressure. Right.
If you have to write only melting point, freezing point.
We can write melting point, uske baad write down boiling point also. Because that's what we'll discuss. Melting is one thing, boiling is one thing. That is why I said when we talk about conversion, we don't consider evaporation. क्योंकि evaporation के लिए boiling point atmospheric pressure की जरूरत नहीं होती है. So boiling point happens, liquid starts boiling, meaning converting from liquid to gas at atmospheric pressure. This is quite important. Melting point may be the same thing. Solid melts to become liquid at atmospheric pressure.
Yes, that boiling point.
Done.
All right, so these specific points we've come across are melting point, boiling point. Agar process reverse hai, like if the liquid is turning into solid, then we call it freezing point. Freezing point, melting point, basically the same thing. Just that उस टाइम पे क्या हो रहा है, that changes. अगर melt हो रहा है तो melting point, freeze हो रहा है तो freezing point. But numerically, the temperature is the same in both the cases. Okay. Boiling point, condensation point is also the same thing. Boil liquid to gas ho raha hai, so it's a boiling point. It's the other way around, then it's the condensation point. But numerically, the number, that particular temperature will be the same in both the cases. Okay. Now,
This boiling point is only known as condensation point.
हाँ, condensation point ज़्यादा like use नहीं होता है. Boiling point is what we talk about. Melting point, boiling point is what we talk about. If it is we're talking about freezing process, then we come across freezing point, but otherwise no. Boiling point, okay. So boiling point का ये हो गया. Sublimation also we talked about. Vaporization, okay. Freezing point, condensation. Talking about latent heat, okay. Now let's do an experiment. Like let's imagine we're doing an experiment on water melting, okay. How do you find out the boiling point, freezing point of all that? उसके लिए do one setup. Basically, imagine we're setting up a beaker. जिसमें you've taken ice. Okay, so to start with ice. Then let's say you start heating this beaker of ice. Okay. Bunsen burner hai. So you start heating the ice and stick a thermometer in this beaker. Okay. Now, aim of the experiment, we want to figure out as time passes, how is the temperature changing? So we'll draw a graph to figure that out. So x-axis पे time है. Time तो चलता रहेगा ना. So that's the independent variable. It's not dependent on anything. So time पहले t equal to 0 is when we start. उसके बाद measure it like if you're measuring it in minutes, then this will be 1 minute, 2 minutes, 3 minutes, 4 minutes, like whatever. Okay, or you can measure it at like 5 minutes ka intervals also. Say 5 minutes, 10 minutes, 15 minutes, 20 minutes, so be it. We'll continue. On y-axis, let's measure the temperature. Okay, let's say temperature y-axis pe. When we started off the experiment, ice tha na. So let's say the temperature was like if 0 degrees Celsius is over here. Let's say temperature was somewhere at -5 degrees Celsius. And then this will be 10 degrees Celsius, 15 degrees Celsius, and we'll continue. Let's say time t equal to 0, we started off with ice at -5. Then when we start heating it, ये temperature क्या होगा? Will it remain constant? Will it increase? How is this going to change? 0 minutes से 5 minutes तक, what is going to happen to the temperature? How will this change?
It will increase. It will increase.
It will increase, right? Heat कर रहे तो इसका temperature increase होगा. अभी increase कैसे रहेगा? Like will it continuously keep on increasing? or will it increase to a point and then stop increasing? Like, till what point is it going to increase?
It is going to increase as long as we continue boiling.
Till it turns into vapor.
Oh, that's a good guess. But before it can get to vapor, ice is solid, na? Pehle melt hona padega. So the temperature will keep increasing until it reaches 0. Then once it reaches 0, if you observe the temperature, it will remain constant until all the ice has melted. Abhi ice pura, once it has turned into water, liquid. Pani hai, we're still on heating it, fire is on. So then temperature is going to increase again. Again, same thing. Temperature will increase until it starts boiling. So when that water is boiling, it will remain constant at 100 degrees Celsius. And then once all the water has turned into steam, which is the gaseous form or water vapor. So once it has turned into water vapor, like it will wait till every single, like the all of the water has turned into a gaseous form.
Why will it decrease? It will keep increasing.
It'll keep, no, like it will keep increasing. You're not taking the fire away. You're giving it heat. Constant supply है. लेकिन यहाँ temperature increase नहीं हो रहा है. So it will not increase until all of the water has changed into steam.
So why is it that phi, so you've made that line and then there is a horizontal line?
Yes.
Why is there a horizontal line? It will keep increasing only na, because like as the Bunsen burner is burning.
But reality में वो नहीं हुआ. So this is ice, like यहाँ पे अभी भी ice है. Temperature increase हुआ. जब तक melt हो रहा है, तब तक temperature will be constant.
Horizontal line is for like ice से water melt हो रहा है और फिर water से gaseous state में जा रहा है, तो उसके लिए वो
horizontal line मतलब कोई process चल रहा है वहाँ पे. So जब तक melt हो रहा है तब तक temperature increase नहीं होगा.
But temperature will increase na, because the fire is continuously constantly there.
But that is the thing. After melting completes, when it is water, then it will start increasing again. But as long as that ice is turning into water, as long as melting is still taking place, the temperature will remain at 0 degrees. Okay. Again, boiling point reach hone ke baad, so this, if you look at the temperature, this would be 100 degrees Celsius. So this horizontal line again is boiling. While it is boiling, this will take place. And after it has boiled, जब पूरा water vapor बन गया, जब steam बन गया, तभी again the temperature will start increasing. So this sort of a graph, this is called temperature time graph. Temperature time graph. Pretty obvious, right? We are looking at the relation between temperature and time. Like as time goes by, temperature kaise change ho raha hai. It's a temperature time graph. And this is what is happening here. Now, Dhriti, you faced, like you kept questioning ki beech mein horizontal kyun ho raha hai? Like why, even if you are supplying heat, it's supposed to increase, right? Natural tendency, if you think about it, agar kuch heat kar rahe hai, to uska temperature increase hona chahiye. तो यहाँ पे increase क्यों नहीं हो रहा है?
Because the process is taking place. So ice, like when heat acts on ice, that is when it's melting.
Yeah. So that is what is happening here. So initially when you're like, let's name these points, call this A, B, C, D, E, and F. So initially A to B, heat energy is used to increase the temperature. वो तो obvious है, हम heat provide कर रहे हैं, उसका temperature is increasing. Heat energy का direct conversion increases temperature. लेकिन B to C क्या हो रहा है? We are providing the heat energy that is still on, but instead of increasing the temperature, this heat energy is used in melting. So melting is essentially what solid is being converted to liquid, right? Solid में क्या है? You have strong intermolecular forces of attraction. पूरा it's very rigid. They're all held in their own place. So whatever heat energy you're supplying, ये bonds को break करने में use हो रहा है. That is what is melting. इसलिए like because you're using up all the energy to break the intermolecular forces of attraction, you don't find any increase in temperature. Like temperature increase करने के लिए और कोई energy बचा नहीं है. That is why the temperature is constant during this time. So again, C to D liquid है. So यहाँ पे कोई intermolecular force of attraction increase करने के लिए like nothing is breaking there because it's in liquid form throughout. So whatever heat energy we are supplying, so that is again used to increase the temperature. Then after we get to D, same thing happens. So D to E also, the heat energy is used in boiling. So again, you're using, like boiling is liquid to gas, you're using up all the energy to break the intermolecular forces of attraction. So liquid में all of them are close by together. उनको break करके दूर दूर करने में you're using up all the energy. So there is no more energy left to increase the temperature. Where is this heat energy going? It's going in breaking the bonds. Okay. And अभी सारे bonds break हो गए, like everything is turned into gas. So E to F, again you use it in increasing the temperature. So this particular concept, temperature time graph, इसको पढ़ना, how, like what do you understand from this? This is quite important. Like it's a very popular 5-mark question. We'll have questions.
Do we need to draw this?
No. So the kind of questions you'll be asked is you'll be given a graph and they'll ask you like ये सारे नहीं रहेंगे. Like they'll just tell you, okay, this is the temperature time graph for wax, which has been recorded. Now explain what is happening from C to D, or what is the state of wax if from D to E. Is it solid? Is it liquid? Is it gas? Is it a mixture of solid and liquid? Melt हो रहा है क्या? So you'll be asked questions based on reading the graph.
When it is in the process of melting, so we'll say solid liquid का mixture.
Yeah, if it's in the process of melting, the way you answer it is a mixture of solid and liquid. Wax is melting at this stage. Like write it like that way. Okay. Now this, like let me, so abhi notes बनाने के लिए just draw the graph. Draw it step by step the way we did it while we are doing it, and also note down like A to B, what is the state of matter, solid, liquid, gas, and उस stage में क्या हो रहा है, temperature is increasing. Then B to C, melting is taking place, so that's where all the heat energy is going. So note down all these steps along with the graph. So you don't have to write down these details. The main thing is, as time increases, ग्राफ ऐसे दिखेगा, like temperature need to increase, फिर constant होगा, फिर से increase होगा, फिर constant होगा, फिर increase होगा.
Miss, what does L2G mean? Liquid to? Okay, gas.
Can you repeat that?
No, Miss, L2G means liquid to gas, right? In D2.
Yeah. Liquid to gas. L for liquid, G for gas.
Miss, in E2F, increased temperature causes steam, right? Or that is only liquid to gas.
No, E2F में, if you look in the vessel, like let's assume it's closed, what you'll find is steam, like पूरा water, पहले ice था, that has melted into water, boil होने के बाद इसमें बस steam ही रहेगा, and temperature will keep increasing at this stage.
Temperature. So Miss, in D2E, steam will be seen.
D2E, like some water will be there, like you'll find water boiling with all the bubbles and everything.
Done.
Cool.
Done, Miss.
Done? Okay.
Miss, that doesn't need to be right. The drawing. Burner, ice, vessel, thermometer.
क्या हुआ? What?
Miss, the left side drawing doesn't have to be made, right?
No, that's just to give you guys an idea कि ये graph कहाँ से आ रहा है, क्या कर रहा है. Okay. So just to give you a visual of this process, because obviously I can't show an experiment in 2D. So Hani, let me know when you're also done and I'll show you what. Okay. There you go. So this is like, yeah, just watch this video. So पहले bowl में we take ice. Okay. So when ice is melting, like पहले इसका temperature raise होगा when it is at 0. This is like, you can see that solid as they are melting, pehle they are all rigid, then slowly they start loosening up and they start being able to move from one place to another. So liquid में particles ऐसे रहेगा, and you can see bowl में, like while melting you have some solid, some liquid also. So while this is happening, the temperature will remain constant. Like वो horizontal line जो है melting जब हो रहा है. So if you stick a thermometer, 0 ही रहेगा. Now all the ice has melted, ये पूरा पानी बन गया. Now again the temperature will start increasing when you do this sort of a setup. Let's see. So that's what they're testing.
Is at 25.5 sealed container, leaving another one empty. The air on the left is at 25.5 degrees Celsius. As the ice melts, it takes energy from the surroundings.
So this is to prove that melt hone ke liye, like if that piece of ice, if the water molecules are increasing their kinetic energy, they have to take energy from somewhere, right? So when you are not heating it, what happens is, like, this is what happens in real life. So when you put ice cubes in water, it makes the water cold because the ice, while it is melting, it is taking energy from the surroundings. So initially it was at 25.
The temperature of the air in the right-hand container has fallen by about 3 degrees. Energy is also needed to change a liquid to a gas. So what's happening to the particles this?
So again, like when, let's say you're heating it, so temperature increases, that is that increase beach mein. Then when it reaches the boiling point,
time.
let's see.
In a liquid, the particles are free to move around.
So this, they'll talk about evaporation, which we'll talk about later. But when you're boiling, this is what happens. Like pehle jab liquid state mein hai, to aisa hai. Then when you keep giving it energy, eventually the atoms and molecules are going to get enough energy that they start escaping out. Matlab inka energy has increased enough that they overcame the intermolecular forces to turn into a gas. Yeah, so that's what happens during boiling. And once they completely boil up, then फिर like कोई interconversion के लिए energy जरूरत नहीं है ना. So again the temperature is free to increase after boiling is completed. Okay. So now यहाँ पे क्या हुआ? If you focus B to C, where melting is taking place, and D to E, where boiling is taking place. यहाँ पे you're still supplying energy, but temperature increase नहीं हो रहा है ना. So क्या हो रहा है? The heat energy, whatever heat energy is being taken, whether it's from the flame or whether it's from the surroundings, जहाँ से भी the heat energy is being taken, that is used to break the bonds, that is used in the process of melting. So that particular heat energy is called latent heat. Okay. So Dhriti, I'll tell you what to note down, when to note down. Okay. So we have latent, yeah. So latent heat is basically the heat energy that that is absorbed during a process. So why do we call it latent heat? Do you know, have you come across the word latent pehle? This word latent? No. So latent ka meaning is hidden. So iska Greek ya Latin kuch to roots hai. So like you use it in some cases to talk about, you know, like this talent was latent in this child. Matlab it was hidden, nobody knew about it. That way. Latent ka matlab hai hidden. In this context, we call it latent heat, meaning, so latent heat matlab hidden heat. Why do we call it hidden heat? Because if you look at it, is ye wale experiment mein, when we are supplying the heat energy, we don't see where that heat energy is going, kyunki temperature bhi increase nahi ho raha hai. So we can't detect ki whatever we are heating, Where is it going? What is happening to it? So that is the reason they started calling it latent. So if that heat energy is being used in melting, it is called latent heat of fusion, because fusion is melting, remember? And if that heat energy is used in boiling, it is called latent heat of vaporization. Okay. So now coming to the formal definitions of latent heat of fusion, latent heat of vaporization. There you go. Yeah. So latent heat of fusion. So basically fusion matlab solid to liquid change. So this is the amount of heat energy which is going into ice, but not increasing its temperature. So it is basically the energy required to change the state of ice from solid to liquid. So this particular quantity of heat energy is called latent heat of fusion. And latent heat of vaporization is the exact same thing, but for vaporization ke liye. So it is the quantity of heat in joules required to convert liquid at its boiling point into vapor or gas. Okay. So do you guys know that we can measure heat and like we can measure energy? Agar kuch, like if you're increasing the temperature, kitna heat energy dena chahiye? Or if we want to move something, फिर उसमें कितना potential energy है, कितना kinetic energy है? Have you come across measurement of energy pehle? Have you done any problems related to that? No? Okay. So just like how you measure length in meters, kilometers, inches, फिर you can measure mass in kilograms, pounds, सारे units of measurement है ना? That way energy also you can measure. So these things are different units of energy. So one unit is joules. For calories, this I'm sure you guys have heard of, right? So where have you guys heard of calories?
In weight, like when we eat something, so they say this much calories, so you gain these many calories, you lose these many calories.
Right. So what did you think they're talking about when they say ki like ice cream has so many calories or this fruit has so many calories? What do you think they're talking about?
The sugar content.
They're related, but no, it's not the sugar content. Sugar content, like next time, look at the label behind it. Okay, agar koi biscuit packet hai, chocolate hai, whatever food stuff we have, let's say. Okay, let's say we have this food stuff. Piche labels hote hai na? So the sugar, proteins, all of that is given in terms of grams. So you can see here, carbohydrates, sugars, all of that, 13.3 grams of sugars hai. Carbohydrates is 72.2 grams hai. So when you talk about sugar content, protein and all that, it is straight away given in terms of mass only. Like depending on the size of what it is, it's either kilograms or grams or milligrams, mgs. But calories is also, it's a unit of energy. So when we say कि इस खाने से इतने calories मिलते हैं, what people are talking about is when we eat that food, how much energy are we getting out of it? So you eat food to get energy, right? Like if you want to run, live, exercise, play.
So when they say that you have lost so many calories, so what do they mean by that?
What do you mean by you have lost so many calories?
As in, like, does it mean that you have lost so much energy?
Where have you come across someone losing calories?
I don't use that term.
Does she mean burning calories?
You
Yeah,
can burn
calories.
calories. Yes. Burning calories, matlab you used up that much of energy. So yeah, so jogging करने में if you burn 1,000 calories, so jog करने के लिए energy चाहिए होता है ना. Like if you're tired, you can't like run. If you're energetic, then you can run, right? So उसके लिए like वो काम करने में you have burned this much amount of energy. So that is measured in calories. So joules is also the same thing. Just like how length के लिए you have centimeters, meters, and on the other side you also have inches. You have different systems of measurement, right? Inches एक unit है, centimeters दूसरा unit है. That way energy के लिए calories is one unit, joules is a different unit. So
Miss, both of them for energy.
yeah. So joules is what you use in all these scientific measurements and everything. Like just like everyday life के लिए temperature you can measure in Fahrenheit or Celsius, but when you're doing scientific calculations you stick to only like Kelvin. Or you guys have done motion, right? So motion में what is the standard unit for measuring velocity?
We haven't reached that part yet.
So we haven't reached that point.
Oh, you haven't reached there yet. Okay, never mind. ठीक है. So like there's a standard SI unit करके एक होता है, standard system है, and then everything else that you use depending on convenience. So the SI unit, standard unit, energy के लिए is joules. So length के लिए you usually use it in meters. Even velocity, like speedometer में kilometer per hour and all, you use it in everyday life. But when you're doing calculations, SI unit, you know, if you're working for NASA and all, velocity of the satellite, rocket, ये सब करना पड़ता है ना. So you need to use one standard system of units. You can't use whatever you want. So that's SI unit. That is meter per second for velocity. Energy के लिए it's joules. So these definitions, latent heat of fusion, vaporization, whenever you come across it, ये सारे numbers you'll be given in terms of joules only. So for example, latent heat of fusion is the quantity of heat energy, the heat required to change the state of ice from solid to liquid. This is known as latent heat of fusion. And as an example, pani ke liye, it takes this much energy to change 1 kilogram of ice from solid to liquid. So 3.34 into 10 to the power 5 joules per kilogram. Okay. So if you're writing the definition, this is the formal definition. Latent heat of fusion is the quantity of heat in joules required to convert 1 kilogram of the solid at its melting point to liquid without any change in the temperature. So vaporization, if you compare, definition exact same रहेगा, is the quantity of heat in यहाँ पे भी joules required to convert again 1 kilogram. The only difference is, because we are talking about vaporization, liquid at its boiling point to vapor or gas without any change in the temperature. So you can see, ice melt करने के लिए it's 3.34 into 10 power 5. Steam में convert करने के लिए you need a lot more energy. So that latent heat of vaporization of water is 22.5 into 10 power 5 joules per kilogram. Okay, so this is the concept of latent heat of fusion and latent heat of vaporization. So all these concepts are important. They will come into significance, like they are required in industries. Okay, so note it down. I'll tell you like an example of where you might use them.
Do we need to write latent heat of vaporization as well?
Yeah, just the definition.
So the first para, right?
Correct. Yeah, that sentence. So the values you don't have to remember. If you're given any numerical, they will be given to you. It's not something you have to by heart. But the concept you need to know. Like if we say joules per kilogram, you need to understand what it is. कि इतना joules चाहिए पर हर एक किलोग्राम को convert करने के लिए. That way. The definitions you need to know because questions will be asked. Define latent heat of vaporization. Define latent heat of fusion. That way.
But will that 3.34 into 10 raised to 5 be given?
Yeah. If you get any numerical related to this concept, you'll be given that. Another thing, unit for joules, don't use small letters. It should be capital J. Change it to capital J. Shouldn't be small. kg is small because that's kilogram. Joules, it's a name of the scientist. So someone called Joule did all the work for it. That's why his name is taken as the unit. जैसे Celsius, Fahrenheit, capital letter use करते हैं ना, that way. It's the name of a person. This is definition.
This is telling for vaporization. In some places there is a S, some places there is a Z.
That difference is more British English, American English ka case. It's the same. Organization also, one way you use Z, one way you use S. That's the thing.
Means we can write any.
Yeah. I think like education system, we follow British English. That's why you end up with color COLOUR. So,
Neighbor also you put a U.
so I think use Z. I think Z is the British English version. It doesn't matter Z or S. So an application of this, like why do you need to know the energy, especially when it comes to latent heat and energy related to phase conversions and all? See, this is one case. It has been found that burns caused by steam are more severe than those caused by boiling water. So steam, boiling water, even if you take 100 degrees ka steam, like abhi convert hua 100 degrees Celsius ka steam versus 100 degrees Celsius ka water. So if you're exposed to both, steam burns are more dangerous because steam is like pani convert होने के बाद, right? So this is in the gaseous phase, this is the liquid phase. So even though temperature is the same, steam has more energy. Steam has 100 degrees Celsius ka temperature related heat energy प्लस वो लेटेंट हीट भी ऐड हुआ है, लाइक वो कन्वर्ट होने के बाद वाला एनर्जी है. So steam contains more heat energy in the form of latent heat compared to boiling water at 100 degrees Celsius. So this will do more damage.
Because steam has been, has been boiling since a really long time, right? Boiling water has been there for a particular period, right?
That's there, yes. But when you write your answer, don't focus on the time, focus on the energy that it has.
Okay.
Steam, दोनों 100 डिग्री सेल्सियस पे ही है, तो the heat energy they have is equal, but steam is also converted to gaseous state ना, तो उसके लिए extra latent heat भी add हुआ है. So that's why heat contains more energy. So that's why it can do more damage. Okay. So that's one thing. And why latent heat is important, like why are these calculations important, is when we look at industrial processes. Have you guys heard of this series called Chernobyl? Or have you heard of Chernobyl? So Chernobyl में like 80s में एक बहुत ही बड़ा accident हुआ था. So Chernobyl में, so it's in Russia, it's in Ukraine actually. So it's a nuclear power plant. So uranium say, from the radioactive energy, they use it to generate electricity. It's a nuclear power plant. So 80s में क्या हुआ? There was some fault in the systems and there was like this huge explosion, a lot of radioactivity. It was a literal disaster. So it, like, a lot of things had to be redefined around safety and all because of that. But places like nuclear reactors and all, or even in factories where reactions take place, agar koi explosive, like बहुत सारा heat energy produce हो रहा है, if you're using boilers and all, abhi you can't keep them overheated, right? Even in cars, like radiator may you add some water, right, from time to time. If you've gone on long distance drives, you must have seen people adding water in the engine wala area. The reason you do that is water is very good at keeping things cool. It is very good at absorbing all that heat energy. It has a capability of absorbing a lot of energy. Okay, just a second. Yeah. So in order to figure out ki exactly kitna pani dalna chahiye and all of that, so this latent heat or heat energy calculations will come into picture. So if I want to decrease temperature by 10 degrees Celsius, let's say 200 degrees Celsius pe tha, I want to bring it down to 150, 160 degrees Celsius because that's a safer temperature. So 40 degrees कम करने के लिए उतना heat energy absorb करना चाहिए पानी, तो कितना पानी यूज करो? 1 liter, 2 liters, 1.7 liters. So in those types of calculations, this latent heat of fusion, latent heat of vaporization comes into picture. It'll be used, that sort of context. Okay. All right.
It's like put them into liters.
Liters, kg, same thing, na? Okay. All right, so that's it about the change in temperature. Like we've seen temperature change kiya, to how it affects the state conversion, solid liquid gas, and we've also seen energy changes, like calculations related to it, latent heat of fusion, latent heat of vaporization. Okay, so this is the graph, latent heat temperature time graph. Then effect of change of pressure. So this is like one thing we are left with. We can pick it up later, like school maybe abhi start nahi hua na, we can pick it up later. So this is almost, we are 90% done with the chapter. We just have to discuss pressure and we just have to discuss evaporation. So next class may we can complete this and also like do a lot of questions.